Hey, we have another update for the Gantry project. In the last video, we finished by discussing the third axis, which is the sliding rail. In this video, we're going to explore the Gantry and talk through some of the challenges we face with that.
We're also going to talk a bit about the control box, as we're currently on our second iteration of that, and we'll briefly look at the 3D workspace and show you around the robot as it currently stands. We've tidied up some of the wiring and it's starting to look kind of smart.
Firstly, we've got the sliding rails. We've got the robot. We just need to do a little bit of CAD to give us the mounting plate.
This is our mounting plate. Because we've been a bit loose with mixing and matching parts where we can get them, we had to design this around the parts with the slides on the bottom and then this to fit the robot on the top. And that's why we've waited until now. It's now a case of just a handful of M5 bolts and some T-slot nuts to fit the robot.
But the main thing we needed was the actual Gantry assembly. Actually, that's in the garage. Seth, can you go and grab that? Oh, get you some space for that.
Right.
Now we can mount the robot, sort all the wiring out, and we're all good to go.
And now, so in theory, this is a quick time lapse of assembling that robot. So to start with, we'll mount our robot onto here. One thing I should point out is that there are these two bolts going through the middle that come out here, and these are going to be used later for mounting our belt drive. Our robot literally slots in, like so. It's quite a good fit. What I'm trying to do here is centre this limb with the centre of this plate. So I think it's about there. I'm trying to do it from the camera. I think that's about right. T-slot nuts down there. And we can push that down until we see the holes line up. Like that. And then repeat that a few more times. With our robot mounted in line, we can then invert the whole thing and slide that onto our gantry. And that for us is going to be this way. We then have this, which is a stepper mount, stepper, motor, stepper mount, and this is used to actuate the left-right gantry movement. So unfortunately, because of the way that these are designed, we have to fix this on first with these screws, and then fix this afterwards and mount that through. We then have the same thing for the other side, but this is mirrored. So in the CAD software, we mirrored that one, adapted it slightly, and then this just has a little bracket on here which we printed separately, and that adapts the hole in this mount down to M8, which then mounts this bearing wheel, and that's for the other end of the drive. Then we'll mount our stepper. This goes on this side, 4 little bolts. The next bit for this is using these. This is a cable management system by iGus, and we actually got this for free, not because they're sponsoring us, but if they want to, they can. I picked this up at a conference, just they were handing out free samples of things, you know how it is, and got a little bag full of goodies, and we've been looking for a use for this for years. So this is actually designed to mount on a 6-axis cobot. This would essentially attach to the limb of the cobot like that, with a strap around this bit, and then this pops in here and clips into place. Like so. We are using it on the top of our gantry, which you barely can see. See now, right? plate just sits in the top. And before we clip that into place, we can route these cables, which we've made up for this project. This is actually probably not the best way of doing this, but we had a bunch of cable, this sort of stuff, and so we just ran sort of 3 of each and then taped them up with electrical tape just to make a concise cable for one motor. And so we've got 3 of those for 3 motors, and then you can just pop into the side of this, and this is how this is meant to work. You can just push that in like that, and I'll just go along and do that for the whole thing, for all 3 cables. So the next bit, we spent quite a while trying to work out how to do best. This is attaching this bit to the robot carrier, and what we settled on was coming down behind here, and then this is another one of those clips, but this has the Velcro strap on it, and we can just clip that on there, like so. That's now mounted, and then loop this onto this servo, and that's it. Cable management done. In here are those bolts that I showed you in the back of the carrier plate, and onto that we can attach our belt. Now, belt drives are quite fiddly, but we actually found that the easiest way to connect it was to interlace 2 sets of teeth, lock them together. This end we've taped because that was our end that we were going to vary, but the other end we just used some copper cable, and that sits in here, hooks onto that central bolt in there. This goes around our bearing on this end. This end then posts past those bolts from earlier in the middle, loops around our drive stepper, and then stretches back to the bolt on the other side, and that's on. It did take us a little while to get the right length, but that's it. For the control board and the cabling for the control board, we still have this set up. Ta-da! So this was our V2 controller, so we've got linear potentiometer here, same as before. This is for the gantry, so that will control the stepper. These 2, same as before, are for limb 1 and limb 2, or link 1 and link 2 of the robot, and then this is our end effector. This is housed or built, designed in such a way that this Arduino can sit in there comfortably, push fit. That works fine, but the problem is at the moment this is still too chaotic in terms of cables for that to really be feasible, so we've just been letting that sit. All of that needs an Ethernet up later once we've got some perf board or something. This is our stepper driver. This board can also be used for driving 2 DC motors, and because you have 2 DC motors that you can drive forwards and backwards, you essentially have 4 independent channels, and so this works fine for the stepper, and Ethan will show you the code for that. Coming out of that are the jumper cables that then connect to this, which is a standard stepper cable for a 4-channel stepper. This then plugs straight into our stepper, like so. These cables are coming from the robot and are for our servos, and we can wire them up, and with that all done, we can do our breadboarding power supply.
I'm going to update our script for our workspace, and we can view it in 3D. So just to quickly run through, L1 and L2 are the lengths of our links, theta 1 minimum and maximum are still the same, and this is the range going from minimum to maximum. So then we have our X, Y and Z points, and in theta 1 range we find the minimum and the maximum, because theta 2 is dependent on theta 1. We calculate the X and we calculate the Y. Then if theta 2 is at its min or its max, or if theta 1 is at its min or its max, we then append the points, and then we show the points. And now if I run this, we get this. It's a little bit easier to see, plot in the center. So yeah, as you can see here, I've only done up to 50. The bar is a little bit longer, but hopefully you can see that this is what we have for the workspace in 3D. Hope this has been helpful and informative. See you back in the video.
You may have noticed our clothes have changed. We actually ended up recording this once before and then not having the audio on the recording, so we're recording this bit retrospectively again. Ethan's just finished writing the code to visualize the workspace, which you will have just seen due to some editing magic. And whilst Ethan was doing that, I was assembling everything here behind me.
Now we have 3D visualization and we've done the difficult task of integrating everything. You can finally try it out. We have our links for the robot on linear potentiometers, and then we have the gripper on a dial. And they all work fine, so we can play around a little bit.
Because the controls are on potentiometers for the joint angles, this is actually really unintuitive to play with, as you're essentially working in joint space rather than Cartesian space, by which I mean you don't have control over where the end effector is, you have control over which direction the links are pointing in. And this could be a really nice way of introducing the concept of forward and inverse kinematics, which we won't go into now as we're nearing the end of this project. Whilst I would be happy to say that this project is done, unfortunately, true to our fashion, we've gone a bit overboard and we do want to do one more video on this. In that video, we will discuss kinematics and we'll make a new end effector for the robot and set it up as a camera for future videos so that we can utilise this workspace with sort of precise camera control. We think that that will make it into a somewhat functional piece of kit rather than just, at the moment, what is essentially our Zoom backdrop.
Yeah. And in that final video, we also want to tidy up the control space, get everything onto a PCB or at least a perf board, unless PCB we are watching on sponsor. I'll also do a separate video where I go through all of the code for this final iteration, line by line. We did actually have some challenges with the code. Turns out stepper control loops have to be very quick, and talking to the serial monitor is very slow, and it took us a very long time to work it out.
Yeah, I mean, other than that, everything so far has been very achievable and can be done by anyone, no matter their skill level. I mean, if I can do it, you can do it. And I think that's probably it from us today. We've done the Gantry system, the controller, the new workspace, and got the damn thing moving. I mean, that's not bad.
Yeah. As ever, let us know if you have any questions. We'll do our best to answer everything. Thank you for joining us on this journey. It's been our first real project and actually been quite surprisingly challenging, but also incredibly rewarding. You'll definitely be seeing more of us in the future.
Yeah, thanks again.
Bye for now.
Grab the whole man.
Yes. Oh no. Oh. Acceptable casualties.
God, it sounds horrible. It's like, it's really bad. Nice. Well done. And there you go. That's it.
Yep. That's all I can do.